Hi guys, welcome to my YouTube channel. Today I'm going to be discussing data models. How do you design a data model in Python? I'm going to be covering what is data model. You must have heard about data model, but what does it mean? And what are the key components of a data model? Importance of data models. Why do we even do data models to start with? And I'm going to be having a practical examples on how you can implement data model. We're just going to build a music database with SQLite. So let's go over to my laptop and I'm just going to walk you through this to make it quite interesting for you to be able to follow. I have all of this script out and I'll be putting the link to this on the description so you can always go over it and read about it. What is a data model? A data model is an abstract representation of the elements within a system and the relationships between them. It provides a systematic way to define and manipulate data, guiding how data is stored, retrieved, and updated. Because data talk to each other, you have different tables existing within the database. They have different relationships, and you could have the dimension and the fact tables that need to connect. And because of that, you design data model in such a way that your data is very, very efficient within your organization. So essentially, a data model is a conceptual framework that describes how data is interconnected and how it flows through an organization or system, just like I described. And we're going to be coming to the importance, but just to give you some key components of a data model that you should know, we have the entities. The entities are objects or concepts that exist independently and have unique identifiers. In a business context, entities might include customers, products, or orders. Just think about entities like you have your table, you have your employee table, you have your customer table. These are entities. And when you look at the diagram I have, this is from Good Data. When you look at it, the first table here is what you could call your entity, the product table. The category table is also an entity. The entity contains the attributes, contains the keys, and contains all of the records within the data. So what are attributes? These are characteristics or properties of an entity. For an example, a customer entity might have attributes like name, email, and phone numbers. So the attributes are what you could call your columns, but when it comes to data model, we describe columns as attributes because they are characteristics of the entities, which is the tables that you have. And relationships is something we've talked about partly. These define how entities interact with each other. Relationships can be one-to-one relationship, one-to-many, or many-to-many, depending on the nature of the data you have. Back to my diagram here, where I have the product table and the category table. You can see there's a relationship between the category ID and the category ID on the product table. So there is a one-to-many relationship from the category to the product. So the product is the parent table, while the category is the child table. And that is why you are having the one-to-many relationship. And you can see the records. The records are the data you have within the entity. So it could be the rows that you have within the entity. You have the primary key, which is unique for each of the entities. So one of the attributes is the primary key. Similarly, you can see on the category entity as well. But what are the importance of data models? Why do we go to the hurdle of doing data model? Why don't we just have a gigantic table, one large table where we can read data from and do all we want to do? Well, data models play a critical role in various aspects of system development and data management. So one thing is that data consistency. If you want to ensure consistency of data by providing a structured format, data models can help maintain consistency across the system, ensuring that data is accurate and reliable. Everybody wants to work with a reliable data. You want your data to be accurate. You don't want to be working with inaccuracies, inconsistencies within your data. Data model is able to provide those consistencies within your data system. You have the efficient data access. Well-designed data models enable efficient data retrieval and manipulation, which is essential for performance, especially in a large-scale system. Communication tool is another great use when you're talking about the importance of data models, because data models serve as communication bridge between different stakeholders, including business analysts, developers, and database administrators. They just try to ensure that everyone has a common understanding of the data structure and requirements. Let's say you join a new organization, you want to understand what is the data that you have within this organization. You might not be the data engineer, you might just be the data analyst that want to have a ground understanding of the data. It makes sense to have like this conceptual framework of the data within the organization. And data models present that. It shows you the kind of relationship that exists within all of the different data sets that exist in the organization. You are able to see the hierarchy of data movement from the parent entities to the child entities. You understand all of the requirements of data, and it gives you a very good place to start any kind of analytics project you want to embark on. And that is why data models are very, very important. You create these data models that communication is very, very effective between all of the different teams working around a project or within the organization. Business analysts, developers, database administrators, everyone have a common sort of truth, a common reference of data within the organization. They're able to reference a similar place to have an understanding of all the data that exists in the organization. So the last one I just put here, they're different importance, but I just selected this few. A good data model is the foundation of a robust database design. It helps in planning and implementing databases that are scalable, maintainable, and performant. Like I said, if you want to design your database, you need to have the data model. You need to understand how this data is going to be stored, how this data is going to be retrieved. Ask questions like who is going to use the data, how frequently is it going to be used, and what are the systems that are going to consume the data, what sort of reporting analytics tool are we going to be using, and it gives that kind of understanding as a foundation for database design. I'm going to be doing a practical, and the practical is around building a music database with SQLite. I'm just going to go and show you the data that I will be using, and you'll have an understanding on the data first before we start talking about how to do any kind of data modeling with the data. So this is the data I'm going to be using to create my data model. And this is music data. So this is the name of the song. This is the name of the artist. This is the album where you have the song. This is the count. And after the count, you have your rating. Rating, you have your length, and this is the genre of the song. And we're going to be putting this into a data model. I've created a pictorial view of the data model that I'll be working with, just to give you an idea of what the data model we're going to be doing. So we have the track. The track is going to be the one fact table where all of the activities are going to go in. We're going to have the track ID, which is unique. We're going to have the title, the album ID, the genre ID, the length, rating, and count. Essentially, what you try to do in data model is to reduce the number of strings you have within the fact table. And anything you can move to a dimension table, it makes sense for the data model. So you try to reduce as much as possible the size of the fact table and push some of those load into dimension tables. I have an album table and I have an artist table. These are all entities. So there's an artist entity, there's an album entity. Within the artist and the album, there's a relationship between the artist and the album, a one-to-many relationship. And you have a relationship from the album to the track, a one-to-many relationship as well. For the genre to the track, you have a one-to-many relationship. And that's why you have the genre ID here. You also have the album ID here, because the primary key of the album table is album ID, and it connects to this place. Same with the artist, you have the artist ID connecting to the album ID. I'm going to go back to this place and show you my script, and I'm just going to be explaining briefly what the script does for you to understand. To start, I'm going to be importing SQLite. I'm using SQLite in this demo. I'm not using the traditional SQL from SQL Server Management Studio. I'm using SQLite because anybody can just install it, whether you're using a Mac or using Windows. It's just straightforward. It's quite easy to install. I'll be using that in this demo just to show you how that works. I'll be connecting to the SQLite and be creating a database. The database I'm going to be creating, I'll be calling it TrackDB. And I'll be creating that connection. First, I'll execute the script. The SQL script I'm executing goes like this. I'll be dropping all of these tables. The reason I'm dropping the tables is because I might want to run the script over and over again. I just want to drop it each time I run it, but you might not bother if you just want to run this once. And I'll be creating the tables. I'm creating the artist table just the same way I described it on the visuals that I have here. I'll be creating this. I create all of these tables that I need. Then the next thing is to insert into the tables. What am I inserting into the tables? I'll be opening this CSV that contains this file. I'll be reading the CSV, and for each line of the CSV I'm reading, I'm stripping it. I'm using the split by comma because it's a CSV. I'm just saying that take for each of the comma, and I'm taking length less than 7 because I just want to get the valid rows. So the first item on the list, I'm going to be picking it as the name. The second, I'll be picking it as the artist, album, until I get to genre, just the same way I explained it here for you. And I'll be inserting into each of these tables. And this is the normal insert statement of SQL. But the caveat is that I have this question mark to say, I want to insert the values I want to insert is going to be the value of the artist when I'm inserted into the artist table. And the next thing I'm going to be creating is, if you come to this place where I'm creating each of these, I'm creating a primary key that's auto increment. It's just adding, you have 1, 2, 3, 4, 5, 6, based on the number of items I have in that table. So I'm creating my primary key automatically there. And I'm going to be inserting, select for each of these from artist where name is the artist. So I'm picking this artist that I have here, this variable artist is actually coming from the CSV file that I have. And I repeat each of these processes for all of the tables that I have, including the track table. All right, so I have this script here. I pasted it on my PyCharm. You could do the same thing on Visual Studio. I'm just using PyCharm because that is the IDE that I have here open. I'm going to be running this and ensure everything is okay. But before I run that, I'm just going to show you my SQL BI. So this is my SQL BI, and you can look at it. You see that it's practically empty. I don't have any data in it. I don't have any database. It's just flat empty. I'm going to go to run this query. And so I have everything connecting to my SQL BI and everything good. I'm creating this database, and the database is going to go to the file path that I'm using, which is cost4. And just be careful when you're running yours. And I'm just going to close this because I run it prior, and that was the result. So let's run this again. Run. In my run, I've said to print out all of these items coming from the CSV, and after that, it shows that it's finished. Let's go to SQL BI and see if we're going to see this database. I come to open database. You can see the new database that I just created. I'm going to click on it and say open. The database opens with all of the tables already created. And I could come here to browse the data. This is the album table. You can see the album ID, artist ID. All the data is here created. I can come to the artist. I see my data. I come to genre. I see my data. I come to the track, which is the fact table. I see my data as well. So I'm going to leave the link to the script also in the description. Just try this on your own. This just gives you an idea on how you could create a simple data model using Python. And it could create more complicated data models on like the modern data stack. You could do all of that, but This is a way you could introduce yourself to the way data models work and how you can get started with it. See you in my next video. Thanks for watching. Bye for now.